Welcome to Ordered Selections and Grouping. So this is a continuation from our video on counting ordered selections where we looked at permutations. So in some of this we'll deal with permutations, but others will use our factorial notation. Reminder that the recommendation is to deal with the restrictions first, then order the groups, and then the individuals in the group is the next step. A group may consist of one member, and our third example or our final example today has a look where it could be only one member. So our first example, we've got 4 Year 12s and 4 Year 11s. They're standing in a line, so order is important because it's important, whether you're first in line or last in line. How many ways can the line be formed? So that's all 8 just thrown in there. What about if we want it to be that 1 Year 11 and 1 Year 12 student have to stand together? And then finally, what's the probability that all 4 Year 12 students are standing next to each other? So for our first one, so we've got eight people. They're all different. Once you put the first one in, the numbers diminish by 1, so that makes it, and its order is important, so it's permutation. Therefore, we can go, since it goes all the way, you're placing everyone, you can use 8 factorial, or you can use 8p8. So the number of ways of ordering those 8 people in a line is 40,320. What about if we're restricting it to the 1 Year 11 and 1 Year 12 student who want to stand together? So we're going to treat them as one group, and they can be arranged in 2 factorial ways, because obviously the Year 11 student can go in front of the Year 12 or the Year 12 in front of the Year 11. So, but it is one group in itself. How many ways? So now we're looking at, that leaves, now that we formed a group with them, that leaves the other 6 plus those 2, but we're going to treat them as one, and those can be arranged in 7 factorial ways. So the total is 2 factorial times 7 factorial, which is 10,080. So what's the probability of all 4 Year 12s standing next to each other? So let's group the Year 12s and make them like one person, but those Year 12s, those 4, they can be arranged in 4 factorial ways. So the remaining 4 students, so the remaining 4 Year 11s plus that one group make 5 students, if you look at it that way. And they can be arranged in 5 factorial ways. So you've got the 4 factorial for the Year 12s times the 5 factorial, which is those Year 12s treated as one, combined with the 4 Year 11s, and that's 2,880. And because it's a probability, you put that number over the total that we got in Part A, so there's a 1 in 14 chance that the Year 12s are together. The second one. Numbers less than 5,000 are formed from 1, 2, 5, 6, and 8 without repetition. So once again, without repetition means that we're into our factorials or permutations, or ordered selections in this case. And we want to find, okay, so how many numbers are possible, how many of them are even, and how many are divisible by 5. So when we look at the numbers, number possible, so how many we're going to be able to get, in this case, we're not focused on whether it's a 4-digit number. We are focused on all the digit numbers. So we can have a 1-digit, 2-digit, 3-digit, 4-digit. Obviously, we can't have more than 4-digit because then we wouldn't have a number less than 5,000. So we're going to start with the 1-digit numbers. And obviously, all 5 of them can fit into that spot because they're all as 1 digits, less than 5,000. But we could write it as a 5p1 because there's 5 numbers to choose from to fill one spot. So that is 5 for 1 digits. For a 2-digit, we've got 5p2, and for a 3-digit, we've got 5p3. So that's, so far, that's up to there. Now we're going to focus on our 4-digit numbers, keeping in mind that the first 2 digits, since it's got to be less than 5,000, the first 2 digits can only be the 1 and the 2. So now we go with our restrictions. So only 2 digits can fill that first position. All the other digits are then possible for the other 3 positions. So we've got 2 for the first one times, we've then got, once we fill that first position with either the 1 or the 2, we've then got 4 digits or 4 numbers to choose from and 3 positions to fill. So that's 2 times 4p3, which is 48. So the total number is adding those up and you get 133 total numbers. How many of them are even? Well, let's go through our possibilities. So the restriction being even is on the last digit for the 1 digit, 2 digits and 3 digits. So for the 1 digit being even, 2, 6 and 8. So that's for them. For the 2 digit, so the 2, 6 and the 8 can fill the last spot, and there's only 1 position left for the 2 digit. That's obviously in the tens column, and there's 4 to choose from, and we've only got 1 position, so that's 3 lots of 4p1. For the 3 digit, once again, the 2, 6 or 8 can fill the final position. So that's the 3 times, and then we've got 2 spots remaining to choose out of the 4 numbers, so that's times 4p2. For the 4 digits, this becomes a little bit tougher because as one of the last digits, that is the 2, can also be the first restricted digit because it's got to be less than 5,000, we're going to separate them. So if the first digit is 1, then we can still have 3 numbers, 3 even numbers at the end. And so the 1's already taken 1, and you've got 2 more positions to fill because it's 1,000 and something. So you've got 2 positions and there's 3 numbers to choose from because you use one of the evens at the end. So that's 18 for the first digit is 1. If the first digit is 2, well, now you've lost one of your even numbers at the end. So now you've only got 2 even numbers can fill the last spot. You've still got 2 positions because it's 2,000 and something. So you've still got 2 positions to fill out of the 3 numbers left. So it's times 3p2, which is 18. Adding all those together gives us a total of 81. Now for the final one, how many are divisible by 5? So this is where I was saying sometimes your group can have just one number, because in this case it has to end in a 5. So we've got a group of 1. So this is similar to our even, but only 1 digit can fill the last position or the last digit. And it doesn't impact the first digit for the 4-digit number. So we don't need to do what we did in the even one and separate them because the 5's bigger than 5,000 anyway. So this was the example that I was referring to where we can have a group of just 1 number. So to be divisible by 5 using these numbers, it must end in 5. So it's a group of 1. And therefore we're going to treat this similar to the even, but we're only going to have 1 digit at the end, the 5. And because it doesn't impact the first digit like the even one did, where one of our even numbers could have been the first digit, we don't need to separate for the first digit with a 4-digit number. We still need to focus on the fact that it's less than 5,000. So for our 1 digit, we've only got the 5. For our 2 digit, the 5 can be the last digit, has to be the last digit. So that's why we've got 1 times, and then we've got 1 position, so out of the 4 remaining, so times 4p1. 3 digit is the 5 at the end, which is the 1 times 4p2. And the 4 digit, it's got 2 restrictions, so it's got to end in a 5, but it's also got to be less than 5,000. So the 2 and the 1 can fill the first position. The 5 can fill the end, so that's 2 times 1, times, we've got 2 positions left from the 3, so that's 3p2, which is 12, giving us a total of 28. Thank you.